Hello everyone. So here we will continue with the same problem. In this problem we have to find displacement of the structure by unit load method. Okay, so we have two questions here. We have to find horizontal deflection at D and slope at A. So we have done with the horizontal deflection at D. For that we have applied unit load at D, horizontal unit load at D, to find horizontal deflection at D. Okay, so we have a system 1. In system 1, same structure will be there and you have to show the given loading. Okay, and in system 2 is for the calculation of deflection, horizontal deflection at D. Now we have to find a slope at A. To find slope at A, we have to develop one more system and we may call it as system 3. Okay, so in system 3, you have to show the same structure. And what is the question here? The question here is to find slope at A. So when they ask you slope, you have to apply unit moment, and when they ask you deflection, you have to apply unit load. So here the question is we have to find slope at A. You can apply clockwise moment or anti-clockwise moment, it depends on you. Here I have applied clockwise moment, unit moment, and you don't have to show any other load except this load. Okay, so we have here system 1, system 2 and system 3. Okay, so we again I will define these terms. M is moment developed in system 1 because of given loading. Okay, and M1 is moment developed in system 2 because of unit load at D. And in the same manner, in the same way, we have to find M3. M3 is moment developed in system 3 because of unit applied moment at A. Okay, so already we have defined the members, and we have also defined the origin. We know the limits. You don't have to change this parameter. This parameter will remain same. Only you have to calculate M3, moment developed in system 3. And by this formula, we can find slope at A. You know M. You have to find M3 for each and every member. Okay. So now see here, after application of this unit moment at A, you will get some reaction. You can easily find reaction by using equations of equilibrium. Okay, so very first member we have is AB, and origin I have taken as A, means distance will be from A. So I will take a section in member AB, and origin is A, means distance x will be from A. So I have to calculate what is moment developed here. Okay, so I have to go from A to this point. So when I go, I only get one moment which is clockwise, so I will write it as 1. There is no perpendicular force to this member. Okay, so only 1 kilonewton meter you are getting when you go from A to this section. Okay, so next member we have BE. BE origin I have taken here as B. EI they have given in the problem 2 for BE. Okay, so origin is A. I have to take a section in member BE, and origin is B, so the x distance will be from B. So I have to calculate moment at this particular point. Okay, so I have to go from A to this particular point. So when I go from here to here, I get a moment 1, which I have written here 1, which is clockwise, I will take it as positive. And you also have this reaction which is downward, and the perpendicular distance with respect to this point is x, and this will create anti-clockwise moment, 1 divided by 5 into x. Since it is creating anti-clockwise moment, so I have taken here negative. Okay, so next member we have here EC. Origin I have defined already. I have defined the origin. I have defined origin as C, means you have to go from D to this point. Okay, so only one force you have, and the perpendicular distance with respect to this point is x, and this will create anti-clockwise moment. I told you many times, when you go from right to left, anti-clockwise moment will be positive and clockwise moment will be negative. So you are going from D to this point, means right to left, this force will create anti-clockwise moment, and hence we shall take it as positive. Okay, now next member we have CD, and origin is already defined. Okay, so take a section in member CD. Origin is D, x distance will be from D. Now you see here, you have to calculate moment at this point, and since D is the origin, you have to go from this point to this point in order to calculate moment about this section. Okay, only this force is there which is not having any perpendicular distance with respect to this point. There is no perpendicular force, hence moment is 0 at this point. Now you can solve. You can solve theta A, slope at A equals to m. M is moment developed in the system 1 into m3 divided by EI. M3 is moment developed in system 3. We have calculated here. Just we have to substitute in the formula. So the first member is AB. Okay. For AB, limit is 0 to 5. M already we have calculated for AB. Substitute the value of M and into M3. M3 is 1 for member AB. Okay. Plus next member we have BE. BE limit is 0 to 1. M we have calculated moment in the system 1. Substitute here. M3 substitute here, divided by 2 EI. For this beam is having 2 EI. Flexural rigidity is 2 EI. Then we have member CE. Okay, again this is M and this is M3 divided by 2 EI. This is also the part of the beam, plus 0 because M3 is 0. So ultimately the product you will get 0. Directly you can write 0 here. When you solve this equation, you will get these answers, and theta A is equals to 996.28 divided by EI, and the unit for slope will be in radian. Thank you for watching this video.